Hello and welcome to the Global Electronics Report. It's Friday, August 26th. My name is Trevor Galbraith. A lot of innovation news for you this week, so stay tuned and please feel free to comment below, even if it's the recorded version, because we love to hear your feedback. First up today, Vision Engineering manufactures a range of innovative stereo and digital microscopes. To assist engineers in advanced defect detection, the company is working with Bob Willis to conduct a series of free webinars. Bob joins me now by phone from the UK to tell us a bit more. Welcome, Bob.
Hi, Trevor.
Hi. Now, the series already started with a series of webinars on solder joint inspection, counterfeit component inspection, and conformal coating inspection. What results did you draw from that series?
Well, I think that the format works very well for people. The time, sort of around 60 minutes, works pretty well from a technology transfer point of view. Certainly the solder joint inspection and defects was the most popular topic. There's no question about that. But the most interesting, intriguing questions really came on the conformal coating. And as you know, it's still a very popular subject.
Yeah, it's an area that's growing a lot at the moment. So on Thursday, September 15th, you're going to present on crimp connector inspection and quality control. What will be the highlights of that webinar?
Well, it'll be a practical webinar as much as I can make it. There's not a lot of training and education around crimp connectors and wire preparation, apart from IPC, of course. And I've run this event or events like it on a number of occasions before. So I tried to say how to do it and what can go wrong rather than generally talk about the technology.
Right, okay. So then the next webinar is up on Wednesday, October 12th. It's on printed circuit board inspection and quality control. Is that going to be centered around the IPC 610A?
Well, of course, it'll reference it. Basically, that's what most people quote when they're buying printed circuit boards or versions of that. But again, you know me, I try to focus on the practical issues, the things that are most commonly wrong with printed circuit boards, and what people should look out for, the things that actually cause problems in the assembly process. There are a lot of rejects for cosmetics, which in my opinion are not important, personally. It's the functional things they've got to look out for.
Right, okay. So the final webinar in the series is on Thursday, November 10th on inspection of conductive adhesive joints. Conductive adhesives have been used much more and for more sensitive components and miniaturization. What key areas will you focus on in this presentation?
Well, the idea really is to talk about criteria for inspection because when you look at joints produced with conductive adhesives, they don't look anything like what you'd expect from a solder joint. Conductive adhesives, generally speaking, don't have the same mechanical strength. So everything goes into the design, obviously, but you've still got to get some basic criteria so people can inspect to make sure that what they're producing at least meets the minimum requirements, although there isn't really a standard out there. So we hope to create it.
Yeah, the standards are always slow at catching up with technology. Well, Bob, I want to thank you for joining us this morning. I would remind our audience that the webinars are free and you can sign up for them on the Global SMT and Packaging webinars page. There's a link there to the sign up form for the webinars. Thanks very much, Bob.
Thank you.
Okay. So back here, SMT Wertheim have released their latest thermal innovation. In a reflow soldering system, a large part of the energy is consumed by the fans. This is directly related to the volume of nitrogen consumption. SMT Wertheim have recently launched a novel system to reduce both energy costs and nitrogen using frequency converters to independently control the fans inside the reflow oven.
There are two main advantages. The first one is we get the most precise profiling, the most precise temperature profiling on board level. In order to profile a PCB or a DBC, for example, we have two parameters. The first one is the temperature of the process gas of the oven. And the second parameter is the so-called heat transfer coefficient. And in most reflow systems, there is only a limited number of frequency converters. This means the heat transfer coefficient cannot be adjusted well. And with our new system, we can individually adjust each single frequency converter and hence each fan inside the system. This means we are most flexible in terms of the heat transfer coefficient, and profiling is as easy as it never has been before. And the next thing is by getting the opportunity to reduce the frequencies of single frequency converters, we can strongly reduce energy. So reducing 5 Hertz is about saving 20% of the energy consumption of a fan.
Is this designed to be a replacement for reflow profilers, or is it designed to be a complement to them?
It is designed to complement them. A reflow profiler and let's say a temperature measurement also depends on the heat flow inside the component and inside the PCB, and this cannot be replaced by this individual frequency converter configuration. But it is more easy to find a suitable reflow profile for a product.
Okay. Do you foresee maybe at some time in the future that they will talk to each other, the reflow profiler?
Yes, definitely. This is one of the next steps.
Do you have any beta data showing the potential cost savings?
Yes. So as I told you, by reducing about 5 Hertz of the frequency of one frequency converter, we can save up to 20% of the energy. This means in terms of kilowatt hours that can be saved. So it is in about, let's say, 300 to 850 euros that can be saved each year, depending on the shift operation in a factory.
But I assume there's also a potential cost saving in nitrogen volume.
Yes, definitely, because the lower the applied frequency, the more quiet is the nitrogen current inside the machine, and the less oxygen can be transported inside the machine towards the peak zone. And this is another positive effect by reducing the frequency of the fans. We can also reduce the nitrogen consumption. Yes.
The technology centers around the Lambda sensor. Is this retrofittable to existing machines in the field?
As I told you, by reducing about 5 Hertz of the frequency of one frequency converter, we can save up to 20% of the energy. This means in terms of kilowatt hours that can be saved. So it is in about, let's say, 300 to 850 euros that can be saved each year, depending on the shift operation in a factory.
But I assume there's also a potential cost saving in nitrogen volume.
Yes, definitely, because the lower the applied frequency, the more quiet is the nitrogen current inside the machine, and the less oxygen can be transported inside the machine towards the peak zone. And this is another positive effect by reducing the frequency of the fans. We can also reduce the nitrogen consumption.
Okay, a small glitch in our production there. Apologies for that. Dutch electronics goods maker Coöperatief IMI Europe has had a very busy week. It announced the acquisition of a 76% stake in the German company VIA Optronics. VIA is a leader in the optical bonding and displays industry. And, as if that's not enough, IMI plan to open a €30 million plant in the Serbian city of Nis. The country's economy minister mentioned that on Friday. Construction work on the plant will start at the beginning of next year, the ministry said, after signing a memorandum of understanding with the company's executives. The investor plans to employ 1,250 people in the next 10 years. Coöperatief IMI Europe is part of the Philippines-based Integrated Microelectronics Inc., which is a leading world supplier of electronics manufacturing service for a number of industries. The Czech manufacturer of cleaning equipment, PBT Works, is well known for its Super Swash stencil and board cleaner. This week marks the launch of the Mini Swash at NetCon South China. Mini Swash is an entry-level solution for cleaning of metal or plastic stencils, misprints, and PCBAs. The system uses double motor-driven manifolds with spray nozzles and an air knife which ensures a direct cleaning effect. Mini Swash is equipped with dual DI water closed-loop filtration which increases rinse capacity and prolongs the lifetime of filters. The zero drain system meets all environmental legislation and minimises the need for an external connection. The new software system makes it easy to operate, and it can be equipped with a traceability system for cleaned products and optional rinse heating to accelerate and complete the cleaning process. Most technologies eventually trickle down to the consumer level, but nobody was expecting 3D printing from your Android this fast. Precise, affordable, portable and fast, Scandi Pro empowers users to create detailed 3D scans from an Android device in real time using their PMD Pico Flex sensor. Scandi Pro captures features as small as 0.3 millimeters with a 0.25 meter bounding box and 36 millimeters with a bounding box of 3 meters in size. Users can also use Scandi Pro on devices editing for quick cropping, resizing and more. So no more long wait times for spare parts to arrive. This device could revolutionize the factory floor and much more. Well, that's it for this week. Remember to like our page if you like it, and switch on your live reminders. Check back with me next week for more top stories from around the electronics world.